Welcome back to my channel. In today's video, we will solve this equation involving the floor function. The given is the floor of 3x plus 1 is equal to 2x minus 1 half. Okay, so what will be the approach? Notice first that the left-hand side is actually an integer. So it follows that the right-hand side is also an integer. Now, I'm going to establish a range of values for the left-hand side, a range of values for the floor of 3x plus 1, because I think that is easier to come up with because the left-hand side is an integer. Now, if we can establish a range of values for the floor of 3x plus 1, then we can easily identify the possible values of 2x minus 1 half and then solve for x. To do this, I'm going to let n be equal to the floor of 3x plus 1. So if n is equal to the floor of 3x plus 1, then n is equal to 2x minus 1 half as well. Now, I'm going to use the second equation and solve for x and then substitute in the original equation. So if we solve for x, we must have 2x equals n plus 1 half. And so x is equal to n over 2 plus 1 over 4. If we are going to substitute this one in the original equation, we must get the floor of 3 times n over 2 plus 1/4 plus 1 equals 2 times n over 2 plus 1/4 minus 1 half. Now let's simplify this. We should have the floor of 3n over 2 plus 7 over 4 equals, this is 2 times n over 2, that's n, 2 times 1/4, that's 1 half, minus 1 half, that's 0. So we have n in the right hand side. Okay, now I'm going to use a certain property for floor functions. We have this property. This is actually a pretty common property for the floor function. The floor of y is less than or equal to y, but greater than y minus 1. Okay, so with this property and this one, we can have the floor of 3n over 2 plus 7 over 4 less than or equal to 3n over 2 plus 7 over 4, but greater than 3n over 2 plus 7 over 4 minus 1. So here you can imagine this to be y, this one also y, this one y minus 1. Okay. But take note that the floor of 3n over 2 plus 7 over 4 is just n. So I can replace this one right here with n. So we have n is greater than 3n over 2. And then 7 over 4 minus 1, that is just 3/4. So we have 3n over 2 plus 3 over 4. Less than or equal to 3n over 2 plus 7 over 4. So now we can use this compound inequality to come up with a range of values for the integer n. Again, take note, n here is equal to the floor of 3x plus 1. So we can just break this down into two components. The first one is 3n over 2 plus 3 over 4 less than n. The second one is n is less than or equal to 3n over 2 plus 7 over 4. Now let's solve for n. For the first inequality, we should get n less than negative 3 halves. And for the second inequality, we should get n greater than or equal to negative 7 over 2. So it is very clear now that n is greater than or equal to negative 7 halves, but less than negative 3 halves. Now let's use this inequality to identify the possible integer values for n. Clearly, n is equal to negative 3 or negative 2. So now we can use this to solve for x, because take note that x is equal to n over 2 plus 1/4. So let's solve for x. So now we have x equals negative 3 over 2 plus 1/4. That is just negative 5 over 4. So this is our first root. Now the second root is x equals negative 2 over 2 plus 1/4, which is equal to negative 3 over 4. You can easily check that these two values of x satisfy the given floor equation.